Hello students, in our previous module we were discussing about the rate of motion and we had expressed the magnitude of rate of motion in terms of speed. The rate of motion of an object can be more comprehensive if we specify its direction. And when we specify the rate of motion, that is speed, along with its direction, the quantity is known as velocity. And velocity can be changed by changing the speed or the direction or by changing both. So, velocity is a physical quantity that specifies both speed as well as the direction. So, the way we calculate your speed, that is the total distance covered by the total time taken, velocity is calculated as the displacement by the time taken. And here, like your speed, velocity has also the same unit, that is meter per second. So, we say the velocity of an object can be uniform or it can be variable. If the speed is changing equal in an equal interval of time, we can say it's a uniform velocity in a particular direction. Definitely here when we say velocity, we always specify the direction. So, velocity can be uniform or it can be also variable, that it can be non-uniform. So, when your velocity is non-uniform, that means the speed is not changing equally, then in that case the average velocity can be calculated like the way we used to calculate the average speed. That means the total displacement divided by the total time. But what if the velocity is changing uniformly? So, that means during uniform motion, how do we calculate the average velocity? So, the average velocity in case of a uniform motion can be calculated as the initial velocity plus the final velocity divided by 2. That means we take the arithmetic mean of the velocity, and mathematically it can be expressed as initial velocity is expressed as u, final velocity is expressed as v. So, u plus v divided by 2. So, for a given period of time, if the rate of change of speed is uniform, so you can calculate the average velocity by the given formula. Now, during a motion, as we saw that a motion can be uniform or a motion can be non-uniform. So, during a uniform motion, the velocity remains constant for a given time interval. That means the object covers equal distance in equal interval of time. So, during that time we can say there is no change in the velocity. Velocity remains constant in a given direction. But during non-uniform motion, when the object is not covering equal distance in equal interval of time, we call it as non-uniform motion. So, during that time the velocity keeps on changing in different interval of time. So, in that case the change that is occurring in the velocity, that can be also expressed by a physical quantity. So, the rate at which the velocity is changing for a given interval of time, for a given period of time, that can be expressed by a physical quantity, and that quantity is called as your acceleration. And how do we define acceleration? Now, acceleration is defined as the rate of change of velocity. And how do we calculate that? Acceleration can be calculated as change in the velocity divided by time taken. That means if the velocity of an object changes from an initial value of u to a final value v in a time called as t, then the acceleration will be represented as a, and which can be calculated as v minus u divided by t. That means the final velocity, subtract it by the initial velocity and divide it by the time period in which the change has taken place, or the time that has taken in order to bring out that change in the velocity. And here the SI unit of your acceleration is meter per second square. As you know, velocity is meter per second. So again we are dividing it by a time factor second. So the SI unit comes as meter per second square. So dear students, at this point, let's watch a small video in order to understand what is acceleration. So here is the video for you.
I am very hungry. I walk to the pizza stall at a velocity of 1 meter per second. 2 minutes later, as I get hungrier, I walk faster at a velocity of 1.5 meters per second at point B. What luck! 30 seconds later, my friend at point C shares some biscuits. I'm not so hungry now. So I stroll at a velocity of 0.75 meters per second for 25 seconds till I reach the pizza stall. To calculate the acceleration, divide the change in velocity by the time taken for it. Positive acceleration takes place when I walk faster. Negative acceleration or deceleration takes place when I walk slower. In this example, the acceleration is negative, which means that the velocity decreases from point C to the pizza stall.
So in the video, you show that when we start from a point A and we reach another point B, and during that change in our position from A to B, if the velocity remains same, there is no change in our velocity, that at point A and point B, at both the point, if our velocity is same, then we can say for that duration of time the velocity is constant. And as the velocity remains constant, so the difference, that means the change in the velocity is 0. So if the change in the velocity is 0, that means acceleration is 0. Now if we start from point B and we reached at point C, so at point B the velocity will consider as initial velocity, and the velocity at point C will be our final velocity. So if we have increased our velocity from point B to point C, that means we found a positive change in the velocity. So if there is a change in the velocity, that means definitely we have accelerated our motion. So this type of motion where the velocity increases, that means the final velocity is greater than the initial velocity, we call it as accelerated motion. There is a change in the velocity, that means our motion is accelerated. Now suppose we move from point C to point D, and what we observe, we have slowed down, the velocity has decreased from point C to point D. Our final velocity is less than the initial velocity. Here also we see a change in our velocity, but the change is here negative. Why the change is negative? Because the velocity has reduced. So this type of change, or this here the acceleration, instead of using the term acceleration, we use the term deceleration or retardation. We say it as retardation. That means if we have increased the velocity, that will be acceleration, and if you have decreased the velocity, we can say it is a negative acceleration, opposite, that means decrease in the velocity, so we will call it as retardation. So whenever there is a change in the velocity during motion, we can call it as accelerated motion. So I hope it is clear to all of you about acceleration. Here again, your acceleration can be uniform and it can also be non-uniform. At what time we can say that acceleration is uniform. The acceleration will be uniform if the change in the velocity is equal for equal interval of time. Suppose we start from a position A and we reach a position B. Our initial velocities was suppose 10 meter per second, and by reaching point B, suppose the velocity has increased to 20 meter per second, and we have taken suppose 2 seconds to change that from 10 meter per second to 20 meter per second. The time taken is suppose 2 seconds. Now if we move from point B to point C again, within that 2 seconds of time, and our velocity has changed from 20 meter per second to 30 meter per second. What do we observe in both the interval? The time interval is 2 seconds, and the increase in the velocity is also equal. In the first interval also 10 meter per second, and in the second interval also it is 10 meter per second. So in that case we call it as uniform acceleration, because the change in the velocity is uniform. And what will be non-uniformly accelerated? Suppose for a given interval of time, we will keep the time interval as 2 seconds. For the first 2 seconds, let us the velocity has increased from 10 meter per second to 20 meter per second. And from point B to point C, for that particular interval time, that is 2 seconds, the velocity suppose has changed from 20 meter per second to 40 meter per second. What do we see here? That acceleration is not uniform. Why? Because from point A to B, the change in the velocity is 10 meter per second, because 20 minus 10 is 10. Whereas from point B to point C, if the change in the velocity is 40 minus 20, that is 20 meter per second. That means the change in the velocity is not equal for a given interval of time. So we will call it as non-uniform acceleration. So an object can have two types of acceleration: uniformly acceleration and non-uniform acceleration. So I guess you all are clear about what is acceleration. So to understand it in a better way, let's solve a numerically related to it. So here is the question in front of you. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brake such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. So what do we have? What are the information do we have here? We have that Rahul starts his bicycle from stationary. Stationary means the initial velocity will be 0, and it reaches to a velocity of 6 meter per second in 30 seconds. That means the velocity has increased. There is a change in the velocity. Definitely there will be some amount of acceleration that we will calculate. Coming to the second case, when he applies brake, his velocity reduces from 6 meter per second to 4 meter per second, and that reduce in the velocity has taken place in a time duration of 5 seconds. That means here also there is a acceleration, that it is a negative. That means we can say there is a retardation. So we will calculate the acceleration in both the cases. So the first case, if you see, the initial velocity is 0, the final velocity is 6 meter per second, time taken, that is t, is equal to 30 seconds. So by applying the formula, acceleration is equal to final velocity minus initial velocity divided by the time taken, we will substitute these values, and after substituting the value and solving it, what do we get? We get the acceleration as 0.2 meter per second square. Now coming to the second case, the initial velocity was 6 meter per second and it has reduced to a final velocity of 4 meter per second. in a time period of 5 seconds. Then again applying the formula, final velocity minus initial velocity divided by t, that is time, will give us acceleration. And by substituting the value and solving it, we get a value of 0.4 meter per second square, that is in negative. The negative sign indicates that means there is a retardation. So we can say the acceleration of the bicycle in the first case is 0.2 meter per second square, and in the second it is minus 0.4 meter per second square. So this is how you can calculate the acceleration of a body when the velocity is changing in a given period of time. So let's solve another question which is related to the application of your acceleration, and the question is as such: find the time required by a bus to increase its speed from 60 meter per second to 80 meter per second if the acceleration of the bus is 4 meter per second square. So we are provided with the initial velocity, the final velocity and the acceleration. So we need to find out the time required to reach at the final velocity. So how can we solve it? You can also give a try. Take out your pen and paper and give a try. Simple application of the acceleration formula. So let's solve it. So here is the solution for you. Initial velocity u is 60 meter per second. Final velocity is 80 meter per second. Acceleration a is given as 4 meter per second square. We need to find out the time. So we'll apply the formula a is equal to v minus u divided by t, or for time we can apply it as v minus u divided by a, and by substituting the values and solving, we will find it out that the time required is 5 seconds. 80 minus 60 is 20, 20 divided by 4, that gives 5. So the time required to reach a velocity of 80 meter per second from 60 meter per second at an acceleration of 4 meter per second square, the time will be 5 seconds. So these are some examples or problems that you can solve. Many more are given in your NCERT textbook. You must practice them. Now let's move on to the next concept. Now here, as in the beginning we had discussed, we will be representing the motion in terms of graphical method. That means using graph, how we can express a motion. So here comes the graphical representation of motion. The first graph that we will use is your distance time graph. How your distance is changing with time and how we can represent that change in the distance with respect to time on a graph. So the first graph that we will draw is for a uniform motion. That means when the change in the distance is equal for a given interval of time. So for that, what we will do, in the x axis we will take the time, in the y axis we will take the position, that is the distance in terms of meter, and time we will take in terms of second. Now as you can see, the initial, that means when time is 0, when we just about to start, the time is 0. So the distance travelled will be definitely 0. Now we will see that after 1 second, the distance travelled is 10 meter. So in the graph we can plot the point 1, 10, that is time is 1, distance is 10 meter. Now after that, 1 second more, that means at the second, the distance travelled is 20 meter. That means another 10 meter has increased. So that you will plot on the graph. Similarly, at the third second, the distance travelled is 30 meter. At the fourth second, the distance travelled will be 40 meter, and at the fifth second, the distance travelled will be 50 meter. Now after plotting all these points on the graph, when you connect them, when you join them, you will observe the graph, the pattern of graph that we will observe is a straight line. So we can say that the distance time graph for an object undergoing uniform motion or at uniform speed is a straight line. When that motion is in a straight line and it is executing a uniform speed, so the graph will be a straight line. Now moving on to the next, when the object is executing a non-uniform speed or non-uniform motion. For that we will take an example. At the beginning it is at the origin. At the first second, after the lapse of 1 second, let us it has reached at 2 meter, and at the second position, that means after another 1 second, it is at 8 meter. After at the third second, that means after the passage of another second, it is at 18 meter. So what you observe here, the pattern, although the time period is same, but the distance travelled is not equal. That means it is in non-uniform motion or non-uniform speed. Similarly, at the fourth second it is at 32 meter, at the fifth second it is at 50 meter. Now if you plot this point on the graph by taking in the x-axis your time, y-axis the position, you will find here in this case we find a curve. But it is not necessary that always it will be curve, it can be a zigzag line, zigzag motion, because it is non-uniform. So the graph for your object executing non-uniform motion is a zigzag line or it is a curve. So this is the difference you will find in the graph for uniform motion and non-uniform motion. Uniform motion straight line, non-uniform motion curve or zigzag line. Now at this point we will see how we can calculate velocity of an object from the distance time graph. For that, let us take this example. In the graph, as we saw that the time is taken in the x-axis, the distance or the position is taken in the y-axis. Now in order to calculate the velocity of the object, you need to find out the slope. And what is the formula of the slope? The formula of the slope will be your delta y by delta x. Here delta y I have taken the change in the position and delta x I have taken it as change in the time. So you have to take two position. As you can see in the example, suppose for a point at 5 second and 50 meter and 0 second 0 meter. If we consider these two reference point, the slope can be calculated as 50 meter minus 0 meter divided by 5 second minus 0 second. That will give us 10 meter per second. So the first slope gives us a velocity of 10 meter per second. Now let us take another set of point. Second, if you see 5 second 50 meter and 2 second 20 meter. If we take these two set of point and we would like to find out the slope, we can find out again that same way, 50 meter minus 20 meter divided by 5 second minus 2 second. That again will give us 10 meter per second. So we see here also the slope is giving us the same value, that is 10 meter per second. And if you go for the third also, the same way we are finding that slope as 10 meter per second. So from this graph it suggests that the graph that we have taken is a graph for an object executing uniform motion. Why? Because the slope value is same, the velocity is remaining same, 10 meter per second, 10 meter per second, 10 meter per second in all the three cases. So from the distance time graph or position time graph, we can also calculate the velocity of an object. So dear students, we will conclude today's session here. Let's recall what we have studied so far. We started the session by calculating velocity, which is nothing but speed of an object mentioned with the direction. Then we went for the change in the velocity and the physical quantity that can be used in order to calculate the change in the velocity with respect to time, which is your acceleration. We talked about uniformly accelerated body and non-uniformly accelerated body. And we also discussed about the position time graph. So at this point, we need to evaluate ourselves how far we have understood this concept in this module. For that, we will go for some questions. So, the first question that is in front of you is, when will you say a body is in uniform acceleration? I think we have already discussed this part also. We need to define an object or a body which is executing uniform acceleration. So, when we can say that? If the body, the change in the velocity of that object or the body is equal in equal interval of time. That is what we discussed. So, a body is said to be in uniform acceleration if the change in the velocity is uniform or equal for an equal interval of time. Now, the second question in front of you is quite interesting. State the difference between uniform motion and uniformly accelerated motion. So, here if you see, the answer is bit tricky. Uniform motion, we say when the object is covering equal distance in equal interval of time. Uniformly accelerated motion means when the change in the velocity is uniform or equal, change in the velocity is equal for a equal interval of time. During uniform motion, if I say, at that time we will say that velocity remains constant. Uniform motion means velocity remains constant, and whereas uniformly accelerated motion means the velocity is changing in equal magnitude for a given interval of time. So, that is the difference between uniform motion and non-uniform motion. I hope you understood that. Coming to the final question for today's session, what is the magnitude of acceleration during uniform motion of an object along a straight line? It's quite related to the previous question also. Magnitude of acceleration during uniform motion of an object in a straight line. As we discussed that during uniform motion, the velocity remains constant. Velocity remains constant means at point A, at point B, at point C, all the time, at all the position, the velocity is constant. So, there is no change in the velocity. That means if there is no change in the velocity, that is 0. So, in that case, if the change in velocity is 0, you take any time duration, the acceleration you will get also is 0. So, that means during uniform motion in a straight line, the acceleration will be 0. So, here the answer will be magnitude of acceleration during uniform motion is 0. So, the rest part we will discuss in the next module. Till then, go through your NCERT textbook, solve numericals and take good care of yourself. Thank you.